Hello and welcome to this demo of the EVARILOS benchmarking platform. We will show you the entire process how you can benchmark your indoor localization solution. After you log in into the system, you will see that we have 5 different topics to discuss. First, we can download and upload raw data traces. We can also collect our new customized data trace. Optionally, we can also benchmark our complete black box solution. And of course, we can visualize our results and even compare our results. So first, let's start with the download and upload section. Here you can see a list of data traces available from multiple testbeds, multiple interference scenarios, and multiple types of data. Instructions how you can use these data traces can be found below. We work with Google's protocol buffer to serialize this data. The next part is collect new data. And to do that, first we need to select a certain time slot. You can see with just 5 simple selections, we can define a complete experiment. So first we select our time slot to record our data trace. Next we can see that we have 3 testbeds available. The first one is the twist testbed in Berlin. As we can see on the picture, it's with brick walls and spread it over 3 floors. The second testbed is the YLab 1 testbed at Ghent. As we can see, plywood and walls are used here, so it's a different type of building. And finally, a very special one, we also have the YLab 2 testbed. The YLab 2 testbed is one open environment with a lot of metal obstacles. In this demo, we will use this environment to show our platform. As we can see, we can also configure our approach. So we can choose our technology, we can choose a certain channel, and we can also select our transmission power. The next step is to define our interference pattern. Those patterns are dependent on the testbed. So for the YLab 2, we have 5 different scenarios. We can choose for no additional interference. We can also choose for the Wi-Fi interference, for example. And we can also have other types of interference. In this example, we will use the Wi-Fi interference. And finally, we can also select our track. Thanks to the robots in the YLab 2 testbed, we can define multiple tracks. The large fine grid can be very useful for fingerprinting solutions. We can also do a large random track, but in this case, we will show you a small random track. Normally everything is configured and we can send our configuration, but for this demo we will have this little checkbox, so the configuration will start right now. So normally it is planned for your certain time slot, but in this demo we will show it you in real time. So right now our experiment will start. So based on the configurations, the script will execute the right commands. We will show you the testbed, so we have a live robot control. So here we can see we will use robot 13. We can put on some cameras so we can see that he's actually driving. So right now he is docked over there. The experiment is still starting, so we have a little bit of time left. We can follow the process. As we can see right now, robot 13 is undocking, and it's true, robot 13 is undocked and now waiting for his first instructions. Now he will initialize to his first position, his starting position, and then he will start driving. So right now the robot starts collecting data and he starts driving around. So the fixed nodes are anchor points and the robot is our mobile node while he is driving in the testbed. So right now it's only a small demo track, but we can drive them through the entire testbed. Data that is captured right now will be converted into proto-buffers, and then they will become available in the download and upload section. So in this way, a new data trace is collected. So yeah, we won't watch the whole track, so let's go back to the application. Voilà. And let's continue with the visualization of the results. So once the data is downloaded and processed by an algorithm, by a solution, we can upload our estimated coordinates, and then we can store these results in a database. For example, we will select the Televic fingerprinting database. Here, a Wi-Fi fingerprinting solution is used as an example, and then we can visualize its results. At the top, we see some general info. Then we, of course, we see the heat map, the most important part of the visualization. We can see how good or bad the solution was working on a certain location. We can also visualize this with the location IDs to have the exact numbers. Also, the latency is recorded for each location. And you can also see the room accuracy of the solution. And finally, we also have some numbers and a table with all the different metrics are shown. We can go one step further. We can also compare and rank. This is based on an application profile. We can give it a certain name, and we can define multiple values to every metric. We can define a weight factor, we can define the minimum points and the maximum points. Even further, we can also define a metric type. So like minimum, maximum, median, and so on. But we already defined an application profile, for example, for the hospital scenario. So let's use that. Once we select a scenario, the platform will start calculating the scores for all the experiments that are in the database. So right now it's calculating the scores, and then you will rank them from highest to lowest. So as we can see, the winner is the quantile without access point 4, so he has the highest score, together with some other algorithms. And we can go down until a score of 2 normally. So we can see they all have a certain score. Yes, okay. So let's pick, for example, the first one. And I can select another one also from the hospital scenario, for example. Let's pick the Bluetooth trilateration algorithm. So that's another algorithm with a lower score. As we can see right now, we have 2 experiments selected, so we can compare everything. If we select more, then we can only compare the details. I will show you that later on. But first, we can compare everything if 2 experiments are selected. On top, we can see the score details. So we can see why he has his final score, depending on the different metrics. We can see both heat maps, and right now the legend, the scale is the same, so we can compare them very well. As you can see, the scale, the min and maximum are the same for both heat maps, so that's why we can compare the solutions very accurately. Below the heat maps, we can see now for each location 2 different distances, the error distance for both locations. The same for the latency. And also the same for the room accuracy results. So in this way we can compare them very easily. Also, the details of both solutions are visualized in one table. So in this way we can compare multiple scenarios and multiple solutions. If we go back, then the engine will start recalculating. If additional experiments are in the database, they will be included. And in this example, we will select multiple experiments. For example, let's take another few. Okay. One last. Okay, and if we right now we have 7 experiments selected, so we can only compare the details, but here we can see why all these experiments has their score based on the different metrics. So these were the most important features of the EVARILOS benchmarking platform. Thank you for your attention and good luck with it.